Hello everyone, and welcome to part 2 of my astrophotography image processing guide. In this video, I'm going to explain the first steps I take after capturing some new data, and what needs to be done to prepare it for processing. After you've spent the night capturing a deep sky object, you'll likely end up with dozens to hundreds of images that need to be sorted. I use Adobe Lightroom for sorting since it comes with Photoshop, has native support for all kinds of raw files, and I found it easy to use for sorting. Theoretically, any image viewer will work, it just has to have support for the raw files you're using. When I'm sorting images, I either separate or toss out the bad images and send what remains to be stacked. I remove any images where the sequence might have run too long and ended up with foreground obstructions like trees or my house, along with any frames that had significant clouds passing through. These can cause gradients that make your stacked image really difficult to process. If you don't use a guiding setup or your mount has poor tracking like mine, you may also need to go through your images one by one to remove anything with significant star trailing. I'm repeating myself from the previous video here, but taking astro images is analogous to trying to use a stamp without having enough ink. You stamp once and you get a faint image, and that's like taking a single frame of your target. However, you can combine multiple images, or stamps, together to get a clearer, more detailed final image. In astrophotography, we call this stacking. A stacking program, such as DeepSkyStacker, is used to align the images based on the position of the stars, then layer them on top of each other, and average out the value of each pixel to create a final stacked image. Using DeepSkyStacker is somewhat straightforward. You start by importing your frames that you want to stack. This includes lights and calibration frames. Your lights are the images of your target. These should be raw, uncompressed frames. While JPEGs can be stacked, you'll get very poor results because these have already been compressed and processed in camera, so they don't contain the same amount of image data that can be manipulated. There are 3 types of calibration frames that are used to improve your image. The most important of these are flats. Flat frames are almost a requirement for further image processing and are used to flatten your images. They compensate for dust splotches, vignetting, and any other brightness variations caused by your optics. Dark and bias frames are also commonly included in stacking. Both are used to reduce different kinds of noise. You'll notice that when you start adding these frames to DeepSkyStacker, another tab comes up called Group 1. These groups are used when you are stacking multiple nights worth of data. For this example, I'm using 2 nights worth with their own dark frames, and I'm also using some older flat frames, as these are somewhat reusable as long as nothing has changed with your optics. Once all of your light and calibration frames are selected, we need to register them. Registering is where DeepSkyStacker calculates some information on each image, such as the number of stars, detects hot pixels, and gives the image a score based on how round the stars are. Using the Check Above Threshold tool, you can check only images above a minimum score to be stacked. The only thing you need to mess with in the Registering tab is the star detection threshold. This controls how many stars are detected and used for alignment. I usually try to have more than 100 detected, but you can get away with smaller amounts, and selecting too many will just increase the time it takes to stack your image. Once your images are registered, you're ready to move on with stacking. Here, you can see a preview of how many frames are able to be stacked, along with what settings are being used. As with most astrophotography programs, there are a lot of settings, but DeepSkyStacker does help you out a bit by offering recommended settings based on the information it has gathered from your images. Simply scroll through and click on the settings that match your images best. If you are using a DSLR, select RGB background calibration. Per channel background calibration will make your color balance difficult to fix when you go to process the resulting image. If you find yourself needing them, full settings can be found in the Stacking Parameters tab. I do recommend at least going in there and changing your output file to go somewhere you'll be able to locate the final stack from. During stacking, DeepSkyStacker will start by calculating the offsets between each image before beginning. The whole stacking process will take quite some time if you're combining a lot of frames. When stacking has finished, you'll get a window with a preview of your stack. It's important not to do any processing in this window. Simply keep the autosave file called autosave.tiff that was saved in your output directory. This is the stacked image we will be processing in the next video. I recommend renaming it in a format similar to this so that you can always see the information on that stack without having to load it into DeepSkyStacker again. If you find that you need further help with anything I discussed or might have brushed over, leave a comment and I'll try to respond myself, or you can join my Astrophotography Discord server and ask for help there. In the next video, I'll be showing you how to take your stacked image and do some basic Photoshop processing to it. If you want to see more videos like this, then get subscribed and turn on notifications to be one of the first to watch. I hope you got something out of this. Thanks for watching, and clear skies, everyone.